So we'll go for assembler. What is the role of assembler? What is assembler and two pass and one pass assembler? So assembler translate the assembly language program into the machine language format or object file. So it is an assembly language program, and assembler, it will generate the machine language format or the object file. Assembler makes two pass over the assembly file. Pass one reads each line and records labels in a symbol table. So here it will generate the symbol table, and using the symbol table we will produce the actual machine code in a second pass. So assembly language, a symbolic representation of machine language, uses a mnemonics to represent each low level machine instructions or operations. So mnemonics are used for representation of the machine instruction. Assemblers with different syntax for particular CPU or instruction set architecture. Example, an instruction to add memory data to a register of 8086 family processor we are using. So this is example, add AX register and the contents of memory of BX register with AX, where this would be written as add, then your AX BX registers contains into the AX. Add AT&T syntax used by JNU assembler. So this is example of assembler instruction. So role of assembler: source program, then it will, with the help of assembler, will generate the object code. Then using linker, linker will execute the executable code, and loader will load that code for the purpose of execution. So assembler functions: basic machine dependent assembler features, machine independent assembler features, assembler design options. So what is actually assembler? So fundamental function: translating mnemonics operation code to their machine language equivalent, assigning machine address to the symbolic label, then machine dependency, different machine instruction formats and code. So here purpose: read records from the input device. So it will read the input record, copy them into the output device. At the end of the file, write end of file on the output device, then sub to the operating system. So here is your example. So data transfer, read and write. Example, the buffer is used to store the record. Buffering is necessary for different IO rates. The end of each record is marked with null characters. The end of file is indicated by the zero length record. Then we will have the subrouting. That is your jump and subrouting. So that is your jump to subrouting and return to the subrouting. So return and read and write returns are used. Save link register first before nested jump. So these are the some assembler directives. So these are used for the implementation of assembly programs. They are not executive. So pseudo instruction not translated into machine instruction, providing information to the assembler. So these are some basic assembler directives. So we start the program and end of the assembly program. Then byte, single byte, double byte, then word, then we will have the bytes. So that is read and write bytes. So object program. So here the program name, then it is starting address, hexadecimal, length of the program object in bytes, hexadecimal. So this will be the structure of the machine code. Then this is the example, pseudo code for the example. So program copy, save return address, then call the subrouting, then calculate the length, call the subrouting for writing end of file, then write to record the records, go to loop, load the return address, and it will go to the call. So same for this one, finding the maximum. So assembler functions: converts mnemonic operation codes to their machine language equivalent, converts symbolic operands to their equivalent machine address, build the machine instruction in the proper format, convert the data constant to internal machine representation, write the object programs and the assembly listing. So this is an example of instruction as assemble. So this is your opcode, then this will be the address, and this will be from where that is source and source address. So forwarding, So difficulties in assembler is a forward reference. So forward reference, we have to find the future reference of that, where that label is or that function is called. Then this is a two-pass assembler, pass 1 and pass 2. So assign address to the statement in the program. Save the values assigned to all the labels for use in a pass 2. Perform some processing of assembler directives. And what are the functions performed in pass 2? Assemble instruction, generate data values defined by byte or word, perform processing of assembler directives not done in pass 1, write the object program and the assembly listing. So this is structure of two-pass assembler. Read from input data, label, opcodes and operands. So source program, pass 1, it will generate the opcode table and symbol table. So this will be your intermediate file, and then it will be given as a pass 2. So pass 2 will consist of a symbol table and it will generate the object code. So which are the data structures used in assembler? Operation code table, symbol table and location counters are the data structures used in a assembler. So what is actually op table, operation code table? It contains mnemonics, machine code. In machine code, it is instruction format and length. Then characteristic, it is a static table. Implementation, arrays or hash table, easy to search. We are using for implementation arrays or hash. Then symbol table, it contains the label name, value, flag, type of flag and length of that flag. Characteristic, it is dynamic table. We can insert, delete and search. Implementation, hash table, non-random key, random keys and hashing functions are used for the implementation of symbol table. So this is the example. Copy. So these are the instruction, these are the location, and these are the symbols or letters we are using. Then assembler design, machine dependent assembler function features, instruction formats and addressing mode, program relocation, machine independent assembler features. In that we have literal symbol defining statements, expression, program blocks, control sections and programming link. So this is a part of your assembler. Then machine dependent assembler features, instruction formats and program relocation. So instruction format and addressing mode. So which are the different types of addressing mode? Base relative addressing, indirect addressing, immediate addressing, extended format, index addressing, register to register instruction, last one the multi-programming allocation. So register translation, register name, so these are name of register and their values, reloaded in symbol table. Address translation, most register memory instructions use program counter relative or base relative addressing. Format 12-bit address, base relative and base relatives are there, 14, 12 or 20, and 20-bit address field. So this is your 20-bit address field. Then base relative addressing mode. So base relative registers is under the control of the programmer. So here it will specify the structure of the base relative addressing mode. Then immediate addressing mode is there. So this is structure of immediate addressing. Then relocation, program, modification record. So starting location of address field to be modified relative to the beginning of the program.